All right, guys, we are graphing rational functions. There are some notes on the board. You should have copied those notes down. Please note that the notes on the board include steps that you guys do not need today. So the first thing you do when you're graphing a rational function is you factor everything completely. We're not going to have to do that today. Everything we're dealing with today is already factored, or it's in small enough pieces that we don't need to factor. The second thing you do when you're graphing a rational function is that you cancel out common factors, and those common factors are used to find what we call holes in rational functions. They're removable discontinuities, meaning that I can remove them from the equation and then work with a simpler equation. We are also not finding holes today, that's tomorrow. But it's important for you to understand that first you factor, then you find holes. After you have done that, you are going to work with a simplified equation. And again, you guys aren't going to have to worry about that today because all of our equations are already, in as simple a form as you can get them in. But tomorrow, factor, find holes, and then work with a simplified equation. After you have done those things, and again, our equations today don't have holes, and they don't have any pieces that we need to factor. But if they did, we would do those two things first. And then the next step to graphing a rational function is to identify the vertical asymptotes of the functions. And we do that, and guys, you want to make sure that you are always very clear with your work, We identify vertical asymptotes by setting the bottom of the function equal to 0. So in this case, for number 1, I'm going to find my vertical asymptote by setting x minus 1 equal to 0. It is extremely important that you write out all your steps and you label everything, because we do so much with rational functions that if you don't have it labeled, you aren't going to be able to tell what's going on, and I certainly will not be able to tell what's going on. And you guys know what happens when I can't tell what's going on. So this function, to find a vertical asymptote, we always set the bottom equal to 0. This function's bottom is x minus 1, so I set it equal to 0, and I solve for x. A vertical asymptote is a line. It's a line that the graph cannot cross. In this case, it's x equals 1. We're done. That's our vertical asymptote. And so I've shown my work, and I've shown the vertical asymptote that I found. After you find the vertical asymptote, you find the horizontal asymptote. And to find the horizontal asymptote, what we do is we compare the degree of the top and the degree of the bottom. And you'll remember that the degree is the exponent. And it's the biggest exponent usually. In this case, I have x plus 2 on the top and x minus 1 on the bottom. My degree here is 1, and my degree here is 1, because they're just x's. I don't have an x squared or anything. So my degree on top is 1, and my degree on bottom is 1. And when the degrees are the same, as they are here, your horizontal asymptote is y equals the coefficient of the top over the coefficient of the bottom. And I know that's a little confusing. What you do is you compare the degrees, and if the degrees are the same, then you take the coefficient of the top and put it over the coefficient of the bottom. Well, here it's 1x and 1x, so my coefficients are 1 and 1. So it's just 1 over 1, which means that my horizontal asymptote is y equals 1. We have, at this point, a couple of attributes of this function, but we want all of the attributes of the function in order to graph it. So in addition to knowing the vertical asymptote and the horizontal asymptote, I also need to know the x and y intercepts for the function. You find the x-intercept by setting the top equal to 0. So in this case, it's x plus 2 equals 0. Set the top equal to 0, and then solving for x. So we would subtract 2 from both sides. X equals negative 2. Now, our asymptotes are lines, but our x-intercept is a point. It's the point where this graph crosses the x-axis. So we don't write negative 2, we write negative 2, 0. That's what we write. And you want to box that so that we know that you found that. Notice how neatly everything is laid out and how it is labeled. You want to make sure that you do this when you graph these problems, because if you don't, you're going to be in all kinds of trouble. You're not going to know what's going on at all. So first vertical asymptote, horizontal asymptote, x-intercept. And the last thing that we have to calculate is the y-intercept. And I'm going to put that sort of right here in line with the x-intercept. And the y-intercept is found by plugging in 0 for all of your x values. So y equals, and we put in 0 for all of our x values. So that'll be 0 plus 2 over 0 minus 1. And that is 2 over negative 1, which is negative 2. And again, this is where the graph crosses the y-axis, so it is a point, and it's the point 0, negative 2. And isn't that fun? They just worked out to be the same. That doesn't always happen, but in this case it did. And then what we can do is we can graph this rational function. And guys, I didn't give you grids on purpose. I want you to draw me a set of axes. Mine's a little crooked, that's okay, but it needs to be neat. Draw me a set of axes and then graph. So I need maybe 4 or 5 tick marks. Your vertical asymptote is a vertical line at x equals 1. And so I'm going to draw a vertical line at x equals 1. And that's my vertical asymptote. Your horizontal asymptote is a horizontal line at y equals 1. So I'm going to draw a horizontal line at y equals 1. And then what we do is we graph our x and our y intercepts. So my x-intercept is at negative 2, 0, and my y-intercept's at 0, negative 2. Now, at this point, please feel free to throw this into the calculator and look at the graph. But what these points tell me, and the asymptotes, because my line's not going to cross these asymptotes, these points tell me that I have a curve down here, because I've got a point where it crosses the x-axis and a point where it crosses the y-axis. So there has to be a curve down here, something to go through those points, right there. And if I have a curve down here for rational functions that look like this, then I have a curve up here as well. And again, you can confirm this with a graphing calculator, and we'll talk more about it tomorrow. But once you get to this point, you are free to put it into the calculator and confirm that what you think the graph looks like is actually what it looks like. The last thing we need to do, and we need to do it, is identify domain and range. The domain for this function is negative infinity to 1, and then 1 to infinity. That 1 is where our vertical asymptote is. That's where that vertical asymptote happens, right there. And so we have a break in our domain. And our range is negative infinity to 1, and then 1 to infinity as well. And that one is from the horizontal asymptote. Those will not always be the same. It just worked out the same with this problem. All right, number 2 is pretty much exactly like this. So I want you guys to try it on your own. Maybe pause the video and try it on your own. And let's look at number 3 together. All right, so again, first thing we do is we factor everything completely, cross out common factors, and then rewrite a simplified equation. But none of that applies here because we don't have anything that complex. So the first step that we need to deal with is vertical asymptote. And so we're going to do that just like we did on the problem above. Your vertical asymptote happens where the bottom of your function is equal to 0. So where 3x minus 9 is equal to 0. And you're going to then solve for x. So add 9. You get 3x is equal to 9. Divide by 3. X is equal to 3. And again, that's a vertical line, so we're going to leave it as x equals 3 because it's a vertical line. All right, horizontal asymptote. What we do is we compare the exponent on the top to the exponent on the bottom, and whatever that relationship is what tells us what we write down for our horizontal asymptote. So if I look at this, the top exponent, the degree of the top, it's got a 3 in front, but that's not the degree. The degree is the exponent. And so the degree of the top is 1, and the degree of the bottom is also 1. And so that means that my horizontal asymptote is the coefficient of the top over the coefficient of the bottom. So in this case, it's y equals 3 over 3. It's coefficient of the top and coefficient of the bottom. And that is 1. So my horizontal asymptote here is y equals 1. All right. What we need to find next, so we've got vertical asymptote, horizontal asymptote, we need to find our x-intercept next. And so the way we find our x-intercept is you set the top equal to 0. It's 3x plus 2 is equal to 0. Subtract 2 from both sides, you get 3x is equal to negative 2. I'm going to move this over here to finish solving. Divide by 3. You get x is equal to negative 2/3. And again, remember that that is a point. It is not a line. And so that is the coordinate negative 2/3, 0. Don't freak out that it's 2/3. 2/3 is just between 0 and negative 1, and it's closer to negative 1. That's what that is. So don't freak out that you got a fraction. All right. The last thing we need to find for this is the y-intercept, and I'll go ahead and put it up here. It's labeled, so on your paper I would be able to find it because it has a nice clear label, right? All of our things have clear labels, and we've done the work sort of contained under that label. So our y-intercept again is found by putting in 0 for x and then just solving whatever's left over. So this is 3 times 0 plus 2 over 3 times 0 minus 9. And that is, these two cancel out their 0. It's 2 over negative 9, which is negative 2/9. Again, not to worry. It's a fraction. It's just a little bit between 0 and negative 1. It's closer to 0 though because it's 2/9. So our y-intercept is the point 0, negative 2/9, like that. Like that. Okay. And so what we're going to do, again, is we're going to use all of this information and we're going to graph it. All right. And again, I'm going to go, I think, to 5. Make sure that you draw a nice, neat set of axes and that you put tick marks on it and that you label it and it's not just chaos, right? I'm looking for precision, and you can have precision without being given a grid. All right, our vertical asymptote here is at x equals 3, so that's a vertical line at 1, 2, 3 right here, like that. Okay, and then our horizontal asymptote for this one, and we'll label it VA. Our horizontal asymptote, you can't even see that, I'm sorry guys. Our horizontal asymptote for this problem is at y equals 1 again, so here's our horizontal asymptote. And then what we do is we graph our x and our y intercepts, and we see what that tells us about the curve. So I have an x-intercept at negative 2/3, so between 0 and negative 1, but closer to negative 1. And I have a y-intercept at 0, negative 2/9. And so that's also between 0 and negative 1, but closer to 0. And what this tells me, again, is that I have because those 2 points are there, there's a curve that goes through those 2 points here, like that. And because of the nature of rational functions, if there's a curve here, then there is a curve here, like that. Now it is important for us to identify domain and range, so let's identify the domain of this function. It is negative infinity to 3, and 3 to infinity. And the range is negative infinity to 1, and 1 to infinity, like that. And again, the domain stops for the vertical asymptote, and the range stops for the horizontal asymptote. All right, guys, go ahead and try 2 and 4 on your own. There is a key for 2 and 4 with the sub, so you can check your answers once you're done. This is your assignment for today. Make sure you've copied down all of the notes off of the board.